Okay, this particular question, a sector of a circle is given. The radius is defined as r. The angle subtended inside is theta. What else is also given? The diameter. The parameter. What is the parameter? 7 centimeter. Now, you are told to show and express theta in terms of r and show that the area of the sector is the particular expression there. Okay, I need to tell you, whenever you do a work problem like this, they will always start with a constraint, with a certain limit. What is the limit here? You are limited by the fact that the parameter is 7 centimeters. Okay, Yihao, can you tell me how to form an equation that will allow us to get this parameter 7 cm? Okay, you have your 2 radius plus AB. How do we find the arc length AB? If you remember, the formula for finding arc length is theta. You learned last year, can you remember? The formula is theta r. For area of a sector is half theta r square or half r square theta. Okay, all these formula you need to remember. If not, you'll be affected. Don't worry, as we do more, it will start to slowly come back to you. So in that case, like what Yihao said, 2r plus theta r. What is it equal to? The parameter, which is 7. This is the constraint. This is what you are limited with. Now, show the area of the sector. This is the parameter. This is given. Now, like I said just now, how to find the area? What's the formula, Kelting? What's the area formula? Half. I just said just now, a minute ago. Half theta r squared. Now, class, take a look at the one that is given. They told you the half theta r squared, the area of the sector eventually must look like this. Agree? Don't need to copy first. Let me go through the whole thing. From here must evolve up to here. Am I right? Now make a very good guess. This is in terms of, what is this in terms of? R, unknown R, am I right? But the original formula is in terms of theta as well as R. So, your choice is whatever limit that you have, make theta the subject in terms of R and substitute inside here. Am I right to say that? And that is what is always being tested in a work problem like this on area as well as volume. They will ask you to prove certain things first. They will give you the limit or the constraint. Okay, this is a term I use myself. It's not found in the textbook. They will give you some information, subjected to that information. Then, based on the information, you are told to find the area or the volume. In this case, it's the area. So now, is it very clear to you? I know what is the formula for area of the sector. But there is the theta here. The final answer is just in terms of R. My job is to make theta the subject and substitute inside here. All agree? Clear cut, huh? So now, I need to continue simplifying and make theta the subject. So what I need to do, agree? So now, what we need to do is substitute inside here. And hopefully, it looks like this. Hopefully, I'm not too sure. So I substitute inside here. Can I simplify? There's an r squared, there's an r over here. So if I reduce to lowest term, this will be 1, this is the power of 1. R squared divided by r to the power of 1, division of same base to subtract the power. So half r 7 minus 2r. Is this the exact form that is listed in the question? then what do you do? Show. The first part in terms of the proving is always worth 2 marks. Unless it's very difficult, then it will be worth 3 marks. But usually we are very reluctant to give 3 marks, even if it's slightly more difficult, because we do not want to penalize you. So far so good? Okay, let's move on. This is only the first part in terms of proving area of the sector. Look at the next part of the question. Hence or otherwise, find the maximum area. The keyword now is maximum area. Okay? Now I'm going to continue over here. Now look here. This is an extension of what we have done previously. Alright? If you remember, when you see the word stationary, with respect to stationary point in your curve, you remember dy dx is equal to 0. Am I right? It means that your gradient is equal to 0. Now, we are looking at stationary values over in word problem. Okay? Stationary value means it can be either maximum or minimum. And that is why I gave you all the synonyms that deals with maximum and minimum. Now, stationary value, in general, could be maximum area, minimum area, maximum volume, or minimum volume. I do not know what it is. But whenever you are told to find maximum, minimum values, please tell yourself the first derivative will be equal to 0. It's no longer just dy dx. Because my expression is not in terms of y as well as x. Okay? So, the key thing now is the first derivative will be equal to 0. So far so good? Because of stationary values. And remember, stationary value at this present moment involves maximum or minimum value. Now, how do I know it's a stationary value? They want maximum area. And this is my area formula. My area formula is in terms of R. Make a good guess. If I want to find the first derivative, Jason, how do I write down the first derivative for this particular expression? If I have y equal to 2x, my first derivative is dy dx. This is a is equal to something in terms of r. What is your first derivative? dA over dr. Thank you. But do you think you want to differentiate using product rule? Why no? Because you can expand and simplify, and that is the thing about word problem. Don't always think difficult. Think easy. Can we multiply inside the bracket? Because there's no square or cube or any other power. It's just power 1. We can multiply everything inside. This will give us 3.5r minus r squared. Am I right? Is it very easy to differentiate? Ryan, how to differentiate? Now, remember, we are looking at stationary value. In this case, it's maximum value, maximum area. The first derivative will be equal to 0. Am I right? Okay, so now let me equate my first derivative to be equal to 0. What does this tell you? When the radius is 1.75, oh sorry, they say find maximum area. When the radius is 1.75, will you tell it's maximum or minimum? We go back to our work problem again. Previously, when we say dy dx is equal to 0, you find the value of x. Will that tell you it's maximum or minimum? What will that tell you? It will only tell you it's stationary. Same thing. This answer of having your first derivative is equal to 0, this will only tell you stationary values. The first derivative will only tell you stationary values. How do you determine whether it's a maximum or minimum? You need to use the second derivative, or if not, you can use the box method. And I'm telling you, make a good guess. Do you think you want to use the box method or the second derivative? Because it's very easy to differentiate. Okay? So this must lead on to either the box method or the second derivative to determine whether this will be a maximum or minimum. So now we know at r is equal to 1.75, you have a stationary value. Do we want to do box method of second derivative? Let's do the second derivative. It's super easy. If you do the second derivative right now, how do I write the second derivative, Josiah? D square A over dr square. And can you give me the answer? Negative 2. Come on, do we even need to substitute inside? This answer itself is less than 0 or more than 0? Less than 0. If it's less than 0, do you conclude it's maximum or minimum? Maximum. Okay, now look here, class. Because it's a little bit confusing. Mr. Liu, previously you deal with x and y, but now what is maximum? Tell yourself, it's always the numerator. Okay? You are concluding you are having a maximum A. And what is A over here? Area. We have just concluded that we are getting a maximum area, but we have not found the maximum area yet. This is to conclude you are getting a maximum area by the use of the second derivative. But how to find the maximum area? Thank you. Use the R is equal to 1.75. Plug it inside where? Plug it inside the area formula. Agree? We have proven that 1.75 using the second derivative will allow us to have a maximum area. So now, plug in your 1.75 inside the formula for now, can you help me press the calculator? What is the answer over here? What is it? 3.0. Exactly. Okay, and this is how a full question will look like.